All right, good afternoon again, everybody. Quickly, let's work with physics. And I don't have a question. Uh, here's your 2025 pack. And we're going to randomly pick. Okay, we have one person from KZN here. Is there anyone from Free State? I'm not sure. I like to look at things that just neutral to everyone. Anybody from Free State here? Oh, physics quickly today. Physics. No one from Free State. Okay. Can we go with the Free State one? Okay. Doesn't really matter. We just choose any. Where's the question paper before I start opening the memos? Free State English. Okay. We just see how many questions we can do. I know you don't like multiple choice. Yeah, we really do need to work on our multiple choice. But for now, what I'll do is, let's see something quickly. Ooh, I'm seeing some nice stuff. But let's run on the structured questions quickly. Let's see something. Oh, nice. Oh, I'm so much in a hurry to look at that question. What is going on here? Okay, let's see. I hope you still have your formulas. You remember your formulas? Your formula page? Because it wouldn't be so easy for me to display. Those of you at home, I know there's a question paper there. Go grab it. Those of you here, your phone, formula page. Question is on the board. 15 minutes. Please don't skip any definition. Yeah, I know some people are not happy with that statement. We are not skipping any definition. I purposely said that because I am attacking some people. It's personal. I know, Mohammed, it's very personal. I'm attacking you. Because you're going to tell me, no, a day before.
Yeah, the night before.
No, let's try. Guys, I'm giving you 10 minutes. Pressure, quickly. Don't Google the definition. Don't Google definition. Don't ask AI. Did we finish? Thumbs up, thumbs down. Let's see quickly. State Newton's second law in words.
Oh, can I do it?
Yeah.
An object will remain at rest or continue moving at constant velocity so long as a non-zero net force does not factor in.
That's Newton's first law. You see that your laws. I was attacking you. I knew.
Yeah, but then that's the second one.
Nah. When a net force acts on an object.
Oh, wait. When a net force acts upon an object will accelerate in the direction of the net force, provided that and that acceleration is directly proportional to the net force and inversely proportional to the mass.
Okay. Remember, no one is going to start it for you now for you to remember. So you must know your story. Draw a label, a free body diagram. Okay. What forces? Identified forces? Tension. Where's the tension? Tension is going up, and what's coming down? Force of gravity. Please write them in full, please. Force of gravity. And what? Tension. Please, very, very important, write them in full. That's number 2. All right. Number 3, calculate the magnitude of the man's weight. How do you get the weight? W equals to what? mg. This is grade 10. What's the mass of the man? 73. And the weight? What's your answer?
64.6.
Sorry?
64.6. No. Oh, sorry, 715,4 newtons.
715,4 newtons. And then 60 what? Okay, guys, are we okay with that one? It's kind of straightforward question, this one, right? What are we looking for? Calculate the time taken. Now, this is where the work is. Time taken. Now, if you remember, under Newton's laws, we usually do not have time. So if I look at the formulas that have time, what formulas will I be looking at? I'll be looking at Vf equals to what? Vi plus A delta T. There's a time there. Vf squared. No. Delta Y equals to Vi delta T plus half A delta T squared. Then delta Y equals to Vi plus Vf over 2. Now, these are the formulas that have time when it comes to motion. We need to discard some of these formulas. Which one are we discarding? If I go back to the question, you would notice we know that the initial velocity of the man is 0, but we don't have the final velocity. So anything that has a final, cancel it. So which one are we cancelling? However, let's check. Do we know delta y? Yes. Do we know the initial? Yes. Because it's 0, right? Okay. The problem is what? And this A is not 9,8. Why is it not 9,8? It's not a free fall. Because there's tension there. Lovely. So how then do we get A? F net, we go, so because it's Newton's law, now we know that F net is equal to what? MA. Let's choose direction, upward as positive. So this one will be a positive, and this will be what? A negative. So what do I have? T plus negative W, is that fine with you? Equals to what? MA. What are we looking for again? Oh, first we need to calculate acceleration. What's the tension? 780. Plus times negative, negative. 715,4. What's the mass? 73. A. Please give me acceleration. 0, 0,8849. All right. Remember, we're not rounding off yet. Now, can I bring that equation in of my delta y? Delta y equals to what? Vi delta t plus half A delta t squared. What's my delta y? 34. 0 multiplied by t plus half 0,8849. What did you get for time? 8, 7? Wrong answer. 8,77 seconds. Let's check. Those of us at home, are we on the same page? 8,77 seconds. All right.
So I got 8,79.
Did you round off somewhere?
So I rounded it down to 0.88.
No, don't remember. Once you round off, you start moving away from your answer. You only round off at the end.
Oh, okay.
Yeah. So because it's still within a calculation, we carry on that calculation. Okay. 2.5. Will the tension in the rope be greater when the man is at rest or when the man is pulled upwards? Explain your answer. What do you think? Let's think here. This is physics now.
Is he pulling himself upwards or being pulled up?
Well, whichever way.
No, it says the man is pulled up.
Yeah, whichever way. Whether he's pulling himself or he's being pulled. Where will the tension be greater?
Being pulled up.
Why?
Can you provide calculation?
Yeah, you can.
So when you calculate it,
Okay.
they give you tension is 780.
Okay, check something. Let me do this. Maybe it will help you. When moving upwards, right? We did something just now, and that's where the answer is. T minus W equals to what? MA. T is what? MA plus W. When the man is standing, is this standing or at rest? When the man is at rest, still the same formula works. T minus W is still MA because we're seeing the same free body diagram. But now the man is not moving. Acceleration is what? 0. So T minus W equals to 0. If you compare the two, look at the first one. We are adding MA to the W, but the second one is just the W. So which one is greater? T tension when moving what? Up. Are we all in agreement? Tension when moving up. And that's a beautiful way to show your calculations. What's wrong with this guy? Yes, talk to me.
How do you explain the ones?
Okay, in words, you just need to go back to the calculation. I think calculation is just better. Explain your answer. You'll have to just tell us that when the person is at rest, the force upward is the same as the force downwards. But when the person is moving, it's greater. So the best thing is to do this. So when it comes to physics, use more calculations, more formulas to explain.
So if we give amounts at that time, like we say that it's when the person is at rest, it's the 715.4, but when he's moving, it's the 780.
Perfect. That's actually also good. When the person, yes, correct. When the person is at rest, the tension is equal to the weight. And what's the value of the weight? 715. But when the object is now moving, the tension is now what? 780. Beautiful. Beautiful. I hope it makes sense. Michelle?
Yes, sir.
We're good, right? Okay. Here we have a 19 marks question. We're doing good. Is it 1 second later? Are you sure? Oh yeah, it's 1 second later. You are cooked. But I know you got it. 19 marks. Guys, I can't give you more than 15 minutes. In fact, 15 is too much, but I know your brains are not braining right now, so we can do as many questions as possible today. But once we are done, if you are done, just type in done, 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 so that we don't waste time. We can just carry on. If everybody's done, we move. Okay, guys, how did you find the question? Nasty or easy? Okay, let's run. Ball A is dropped vertically. Please, drop does not mean zero. You have to ask yourself, where is it dropped from? If it's dropped from a stationary point, then we talk about what? Zero. All right, so ball, yeah.
Okay.
No, but in this case, it's zero. All right. From the top of a 25 meters high building, 1 second later, another ball B is thrown. So this is a common technique that they use, right? From the same height with a velocity of what? 30. Now, do you see? Okay, initial velocity. Let's quickly start putting the notes down. Velocity here is 0. Velocity here is what? 30. We agree? Am I right? Okay. Define the time projectile. Projectile is an object.
An object that is given an initial velocity, then the only force acting on it is gravity.
Okay, at least somebody's coming up. Projectile is an object that has been given an initial velocity, and the only force acting upon it is the force of gravity. Okay, use equations of motion only to calculate the time it takes ball A to travel. Can we just choose down as positive throughout the whole system? Down as positive. Now, guys, I like to always write what I have. 3.2.1. What is my initial velocity? 0. What are we looking for? We're looking for time. Now, takes to travel 12.5 meters above the ground. Okay, so it's still with 12.5 anyway. Now, if they say 12.5 meters above the ground, halfway. But that's not the 12.5 we're looking for. We are looking for what the ball has traveled itself. That's the one we're looking at. And this object is going where? Down. And we chose down as positive. So my delta y is what? Positive 12.5. What else do we know? Acceleration? 9.8, not negative, right? Because it's always acting where? Downwards. A or G. What are we looking for? Time. I think we do have a formula. What formula?
Delta x.
Not delta x. Delta y, because if you say x, then it's moving horizontally, right? Half AT squared. What's our delta y? 12.5 0 t plus half 9.8. Please just give me an answer.
1.62 seconds.
Okay, please confirm everybody if we are on the same page with 1.62. 1 comma?
So I'm getting 1.60.
Yeah, it's 6.
There's one boy here. There's one boy here who's misleading me. 1.6.
You said my answer was wrong, I changed it to right.
Okay, 1.6 seconds. Are we on the same page, everybody? Confirm? Confirm? Okay, beautiful. Time it takes for, okay, this is where things start going south. Time it takes for ball B to pass ball A. We have to analyze before we even start. And this is where many of us, lose it. Okay. First thing is, for them to pass each other, they are at the same point. We agree. But do we know that point? No. Okay, so I'm going to do this. Go back to the question. And let's say the point where they pass each other is right here. So B and A. What is this? H. From the ground. What is this? (25 minus H). Are we on the same page there? Just trying to analyze. They pass each other at that time. Now the question is, how long did it take ball A to reach that point? We don't know. Let's create a formula for that. Okay, so ball A, initial velocity is 0. We don't know the time. We know the height. Can we use the same formula? I think the same formula would work.
Yeah.
Delta y equals to what? Vi delta t plus half A delta t squared. Let's see. What is the displacement covered? 25 minus h. Do we agree? What is the velocity, initial velocity? 0, 9,8, and we do not know t, right? So can we say that we have 4,9 what? T squared. This is the time of A. We agree? Okay. Let's go to B. What can you tell me about B? When they pass each other, they're actually at the same height. They've traveled the same distance. Can we use the same formula? Okay. Delta y equals to VI delta t plus half A. All right, let's see. They have traveled the same displacement so far. Okay, so what would this be? 25 minus h. Initial velocity is what? 30. Now, what is the time?
Delta t plus 1.
Y plus 1.
It's minus 1.
Which one has traveled longer? A.
It's minus 1.
A has traveled longer than B. So that means the time of, you are spinning your head. The time of B is shorter. So this is going to be the time of A minus 1 plus half 9,8 t minus 1 squared. Okay, so they are equal to each other. Can we just do what needs to be done? Okay, look, I'm going to, because of space, this 25 minus h, can I just bring it here? So instead of writing 25 minus h, I'll write what? 4,9 t squared equals to what? 30t minus 30. What is half of 9,8? 4,9. And this is what? T squared minus 2t plus 1. If we expand, let me steal some space here. What do we have? 4,9 t squared equals to what? 30t minus 30 plus 4,9 t squared minus what? 9,8 t plus 4,9. The first thing when you do this kind of questions is to see that your 4,9 t squared would cancel. Because if I move it to that side, it cancels out. Now what do I have? Let's bring all the t's to one side. What do I have? Negative 30t plus 9,8t. What would this be? What are we left with here? Negative 30, right? Okay. Let's do the maths. What is 9,8 minus 30? 20,8. 20,2. Negative 20,2t. What about this one?
Negative 35,1.
Stop lying. 35. Out of 35.
Negative 35.
No.
25.1.
25.
Yeah, why am I doing that?
25.1.
0.1. So what is your t? Divide both sides.
1.24.
And that's the whole idea of the question. So when they pass each other, they are at the same what? Height. So sometimes the examiner will ask you to find the height where they pass each other. Now we are looking for what? H. You can substitute and get H there. Either in the first equation or the second one.
But it's the time that they are the same. They ask for the time it takes for B to pass.
Time it takes, yeah, that's the time. It takes 1,24 seconds.
No,
Wait.
1.24 is the same.
Okay, wait, hold on. Time it takes for ball. Okay, this T that we got is T of A. No, wait. Okay, in all of this, the T that we are writing is the time it takes A to travel. You're right. So all of this, because I said TA here, right? So all of this is what? TA. So it means A travels what? 1,24 seconds. Time it takes B to pass will be 0,24. Because we said time of negative 1. 1,24 minus 1. All right, that's the correct answer. Do we agree with the last statement, please, of this one? And is there anyone who is lost? Let's quickly engage. We have 10 seconds to ask. If there's anyone who wants to ask, otherwise, give me a thumbs up.
But we both get there at the same time. How is that possible? I'm driving and bus. Yeah. So that's why it's mine as well.
So you would notice A had traveled 1.24 seconds, and B, moving at a faster speed, only travels 0.24. And they are right now at the same spot. This is what happens when you're playing with your younger one and you tell them to start running, and then you wait for them, and then it's kind of a thing. Yeah, makes sense. Or somebody's driving an Uno and you're driving a Benz, tell them to start the journey. You'll find them. Okay. Speed of ball B when it reaches the ground. I hope we're okay here. Make sense? All right. Speed of B when it reaches the ground. What do we need to do? Basically, that's what we are looking for. What formula do you think we should use here? V, number three. VF squared equals to what?
Yes.
Plus 2A delta Y. We're looking for that. What's our VI? 30 squared plus 2, 9.8, and what? 25. Do you want to give me an answer quickly?
37,
37, comma?
28.
Meters per. And we don't need to put direction there. Why? The examiner says speed. Okay. On the same set of axes, sketch a position time graph of ball A and ball B. Now, guys, I want us to draw two graphs. Okay, gentlemen. I want us to sketch two graphs. I want us to sketch both position and velocity. Okay, so if I were to draw a position time graph, both of them were dropped, right? Let's see. This is interesting. Position. In what? In meters?
So,
Yes?
because we chose downward as positive, shouldn't we flip the x-axis?
Okay, wait. We chose down.
Shouldn't our graph be facing the other way?
No, because if look at it. This is what I like to do. Let me clean this. Since we chose down as positive, object is just coming down, and that's all. That's my y-axis, and that's my x-axis. Does that make sense?
Yes.
Because
So when do we flip the graph?
if I had said downward is negative, then I would have flipped the graph.
Oh,
Because-
down would be negative.
Yeah, because my displacement would then be negative 25.
Oh, I see.
All right, so for A, are we okay? 25 meters. Do we know the time it takes? What are we showing? Initial height of the building, times at which the ball is thrown, time ball A passes ball B. Okay, we find like this for A. What about B? Same height, but 1 second later. So, 1 second. That is where B is going to start. Right? And they cross each other at what? 1.24. Yeah. That's the 0.24 is taken care of here. That is why ball B traveled at that time. What are we supposed to show? The time at which at that time they are at the same spot. That's interesting. Okay, at that time they are at the same spot. All right, let's see. So, can I do this? Now that's very, very important. Ball B would finish faster because it already meets it, so it passes it. That means, let me use a yellow one here. Where that graph would go is very important. Yes.
So,
Yep.
what do you mean by the time at which ball A passes ball B?
The time we calculated earlier on. Look at the 3.2.2. Time it takes ball B to pass A. So there's a point where they cross each other, where they are the same point. That's what they mean by the time at which ball A passes ball. It should have been ball B passes ball A, by the way. Not A passing B.
It doesn't pass.
A doesn't pass, but B that passes A. It's an English problem there. But we understand what they are trying to say. Right? Michelle? Okay, so it's just a language problem. But are we okay with the question, with the graph? Makes a lot of sense. May I quickly ask you for the next 60 seconds, draw the velocity time graph of this same question. Let's see, I want to see what it's going to look like. Velocity time graph for the same question. From here we go to momentum, we go to work, energy and power. We know mechanics. I want us to face mechanics today.
So, I have to calculate velocity
You don't need to calculate any other thing.
of ball B. Every graph.
Yeah, we don't need it. The information you have should suffice.
So doesn't B cross at 0.24 seconds?
No. B has traveled 0.24. That's why you would notice the time frame here. This is the journey that B traveled. Do you see? 1 and 1.24. That's your 0.24.
Or when it crosses
Yeah.
A?
So it's traveled that 0.24. Then it crosses A. I want to see what the graph would look like. It's going to look interesting. Velocity time graph. No, of the whole situation. Yeah. VT graph of the whole situation. Doesn't look what? I don't know whether it's going to... I'm just guessing we should be able to draw. Okay, let's see. If I were to draw, maybe that's why they didn't ask, because it's a mess. But let's see. I want to try. Okay, for A, this is velocity, meters per second, and what? Time. All right. A starts at what? 0 and keeps increasing. We agree. Okay. We don't know any velocity. Oh, but we didn't we get a particular velocity? No. Okay. What about B? B starts at 30.
Yeah, but 1 second later.
But 1 second later. So 1 and what? 30. Oh, guys, it's very simple. They don't have to actually cross each other,
Yeah.
because I know that's what is in our head. And remember, they are both free falls. Time. Will they reach the ground at the same time? No, we got the final velocity of what? We have the final velocity of B, right?
37,28. 28, yeah.
37, comma? 28. Yeah. That's perfect.
Now is this why the one in our paper was wrong? Because they said the time when the velocities are same. So then they would have to intersect on this graph.
Oh, maybe. Because when we draw, these lines are supposed to be parallel to each other.
Now we intersect, they don't know.
Yeah. If they intersect, then they are not both free falls. Yes, talk to me.
Hi, sir.
Yes. Is that my lady?
So, yes, sir.
Okay.
Sir, would it be okay if we still look for the final velocity of ball A?
If you what?
If you look for the final velocity of ball A.
When they don't ask you to calculate, it means they don't want you to put it in the value, but just have an idea, because it's a straight line graph. So it's fine, but you don't need it. It gets no mark.
Okay, sir.
Yeah.
Thank you.
So this would be the velocities, velocity time graph. Just know that they are parallel because they are both free fall.
So the gradients of this graph will be 9 to 9.
Absolutely. We can try it.
I really don't.
No, it will absolutely be 9,8. Okay. That's why they are supposed to be what? Parallel. Okay, beautiful. Guys, I hope we are okay. We just keep learning here and there. This one, you can do this one in 5 minutes. Huh? No, I'm not going to run away. So what I'll do is, when we do mechanics, then we'll go back and answer the ones we've done on this. Okay, come guys. Let's go. This one, 10 minutes, man.
I know these definitions.
Huh?
Now I know these definitions so far.
Yeah, you're cooking.
And it's only I'm getting at.
All right, guys, how did we find this? I think this one is a bit more, I'm sure it's more straightforward than, I don't know. What do you think? A car of mass 1002 moving at the speed of 25 meters per second in the eastern direction crashes into the back of a truck of mass 6,000 kg moving in the same direction at 15. Okay, so they're both going in the same. Oh. All right, the velocity of the car after collision is 16 meters per second to the east. Write the principle of conservation of linear momentum.
Oh, the total linear momentum in an isolated system is conserved.
All right, the total linear momentum in an isolated system is conserved. Calculate the velocity of the truck. This is very straightforward because we are simply saying what? Let me just create some space there. We're basically saying the sum of initial momentum is equal to the sum of what? The final momentum. So M1 VI1 plus M2 VI2 equals to what? M1 VF1. Will this work for us? Now, what's the mass of one? The mass of the car? 1,200. Moving at the speed of what? 25. And then it's the same direction, so we cool. 6,000. What's the speed? 15. 1,200. The car. What are we looking for? The car, right? Now, it moves 16 east, so we still maintain positive. Plus 6,000 VF2. I'm sure the math is quite easy. 16? 16,88. Just 8. Okay, guys, are we confirming this answer for me, please? 4 marks in the bag. Answer confirmed. All right, no questions asked here. We move. May our paper just come out like this. Calculate the mechanical energy lost during the car truck collision. Now, what is mechanical energy? It is the sum of kinetic energy and what? Potential. Let's start from there. All right. E-mech is what? EK plus what? But in this case, it's horizontal. The potential energy is 0. So if we are looking for the mechanical energy lost, change in E-mech, right? Would simply be what? EK final minus what? Okay, let me do this. Sum of EK final and sum of what? EK initial. Make sense? Because the mechanical potential energy is 0. Why is potential energy 0? mgh. They are both on the ground, so their height is what? 0. Okay. Let's deal with the initial kinetic energy. Maybe it might be easier for everyone this way. Oh, this formula is long. I don't like it. It's half m1 vi squared plus what? Half m2 vi1, right? vi2 squared. Okay. Half 1200 25 squared plus half 600 6,000, right? 15 squared. You want to please give me an answer there? $1 million what? What am I doing? No, start with 1. VF1 MV2 squared VF2. You said this is 1 million? So it's 1 0 0 0
105
What is it? 1 0
5
0, 5, and 40.
What did you call it now?
1,050,000.
Oh, okay. You know money. Half. What is this one? The mass? 1200. What's our final velocity here? 16 squared plus half 6,000 16,8 squared. What would this give us? 1,000,000, like that. So we can conclude to say our change in mechanical energy. What's the final?
49680.
No, I want us to put that value. 1,000,320 minus 105,000. What's your answer? 4 zeros.
49. Well, negative 49.
49,680. Okay, but what will my final answer be? Now, I shouldn't put a negative. It's a scalar quantity. Okay, that's what I got. But my final answer, can I just put my final answer here? My final answer would then be what? 49860 joules. Don't leave your answer with a negative. And it makes sense because they already told us it's a scalar quantity. But show that you got a negative, then therefore energy lost is equal to that. Why is mechanical energy lost? Yes, talk to me.
Why did you say final minus initial instead of the initial minus the final?
No, every time we calculate change, it's always final minus initial. Anything change, final minus initial.
So the mechanical energy lost is change.
Yeah, what you lost is change. That's change. Okay, anybody help me with 4.4? Why is mechanical energy lost?
So the velocity decreases.
You're trying to be smart here. Velocity of what? Velocity of what? Come, you Sarah, finish the statement.
Okay. So the velocity of the track.
I'll give you so many reasons. It's an inelastic
No, the velocity of the track.
of the truck.
No, the car.
Okay, but you see, both of them actually decreased, right? But this is what I wanted to see. Number one, it's an elastic collision. Okay. Number two, energy is converted. Number three, I wanted to look at something. Guys, you know how they used to say, when they give you two objects, it's always in the newspapers, identify the difference. Ah, come on. When they give you, they draw the same person and they spot the difference. Let's have, come on. Ah, where you have to look for, there's a handbag there with a... Can you spot the difference between these two objects for me? Huh?
Is it empty but after the
Cool.
cars are closed?
Yes. Do you notice after that black thing is telling you they are joined together? When they are joined together, it's an inelastic collision. When they move together as... Oh, but wait. Let me see something. No, but we won't say they move together. We won't say they move together. Okay. Because the velocities are different. 16 and 16,8. So I don't want to... But please know that when they move together as a unit, it is also what? Inelastic. All right. But why... Explain why mechanical energy is lost. Energy is converted, all right, from one form to another. You hear, when there's an accident, you can hear the sound. So it's the velocity, kinetic energy that is converted. It's inelastic. I'll put a star here. Object move as one unit, but not in this case. Object move as one unit. Those are things that will define your inelastic collision. Okay, I hope those answers make sense. I don't know if there's anybody that wants to add something else. Is there any other person, or is there any answer you wish we can correct? But I think I'm fine with these answers. Energy is lost, or energy is converted from one form to another. Okay. Lovely. Sarah, you said you wanted this graph.
Thank you, sir.
Okay. Are you taking a screenshot?
Yeah, I'm taking a picture.
Okay. Tell me when you're done.
I'm done.
All right, beautiful. Okay, guys, let's try. But we're moving away with this paper, hey? Why is that with maths we don't do so much? We do one question. Oh, no, I do one question, one topic, and okay, but this time around we're running through a paper. Oh, no. This is beautiful. I don't want to. I knew when I said, oh, no, you go like, okay, since you said, oh, no. No, guys, this is a beautiful question. I love it. I love it. Okay, so we're going to do it step by step. We're going to do it step by step. Okay. First, we have 4 marks. Please read the question. 4 marks. Read the question first before you read 5.1. I know. This one is very simple. I promise you. 3 minutes. Are we done? Okay, let's read. We have just 2 questions there. An 8 kilogram steel ball initially at rest is pulled upwards by an electric motor with a constant applied force of 45 newtons. The ball moves at constant speed in each of the sections X, Y, and YZ along a rough inclined slope as shown below. Each section is 4 meters long and exerts a different frictional force on the steel ball as it moves up the incline. The incline makes an angle of 25 to the horizontal. The graph below shows the kinetic energy of the object versus the distance of the entire motion. What is non-conservative force? It's a force for which the work done depends on the path taken. This one is none, so it depends. If it is conservative, it does not depend. So please take note, it's not the force, it is the work done by the force. That's the where Leonard's right force that depends. No, it is the work done by the force. Okay. Use a suitable formula to show the physical quantity represented by the slope. Okay, let's see. They're bringing in kinetic energy. Okay, if we let's see if we say y2 minus y, okay, gradient. No, they say gradient. Let's see if it's gonna make sense. Slope is gradient, right? Which is basically change in y over what? And what is this? EK over what? The distance, right? Distance. What's the formula for EK? Half mv squared over what? Distance is x. right? Okay, if we write this nicely, what are we going to get? 1 O M VF squared. Okay. Over 2m, over 2 delta x rather. All right, let's see. Mass, velocity squared. Where is there a formula that connects all of this together? That's what we need to start looking at. That's what we need to look at. Let's quickly analyze. Since we are doing work, let's be smart. What's the formula for work? Work done is what? Right? If I divide both sides by delta x, what do I have? Force will be work done over what? But can W be equal to mass times velocity? Okay, let's see. Because already we have delta x at the bottom, but we need to prove that W is m delta v. No, this is interesting. This is interesting.
No, but W net is equal to delta K.
Okay, wait. What is W net? Hold on. W net is actually change in kinetic what? Energy. Right? Okay. So W net is equal to half. But the same W net is equal to what? F net delta x equals to what? Divide both sides by delta x. 1 over 2 mv squared over what? So this is F net. Interesting. First time I'm doing such a beautiful question like that. Did it make sense, guys? So we found a gradient. Interesting. We found a gradient. This is my gradient. And we're trying to use the formula. So if I use work net formula, which is change in kinetic energy, half mv squared, but the same W net is F net delta x cos theta. Cos theta is 1 in this case. Now if I do that manipulation, you would notice that the gradient and the F net both have the same what? Equation. So use a suitable formula to show. This is exactly what I write. To show the physical quantity represented by the gradient. I think this should be more than 1 mark or 2 marks, but they know that a lot of people will struggle. That's what happens when a question, some of you get the question right and say, but this question should be 5 marks. They're actually considering how many learners are going to get that right. So if they make it 5 marks for you, then they're taking 5 marks from a lot of people. This is more than 2 marks. But are we okay? Lungelo, where should I cross multiply? No, we don't want to cross. We're not solving. Okay? We're not solving. Yes, Michelle, where are you lost? Okay, the examiner says the slope. Let's go back. Let's go back to the whole question. So this is, if you have ever watched any of my lessons where I talk about graphs, these are all the things that I discuss. Examiner says slope. The slope also means what? The gradient, which is your change in y over what? Change in x. What is on the y-axis here? It is kinetic what? Energy. And what's on the x? Distance, which is delta x. Is that fine? That's what we use in representing displacement. But what is EK? Okay, even if we don't change this, I think we could still work around this, even if I don't change this. Yeah, we could still work. So I'm looking for a formula of work that has kinetic what? Energy. Now, formula. What is work net? Change in kinetic what? Energy. But what is work net in terms of force? It is F net delta X. Cos theta will be cos 0. So F net delta X cos theta, check that. Divide both sides. What do you notice? F net is change in what? Kinetic energy over. By the way, remember I said change in Y, so I could put a change there as well. So what do you notice? My gradient is change in, yes?
So what happens to cos this?
Two?
Cos theta.
I just said that theta is 0. Theta is 0. And what is cos 0? 1. Alright? Because F net, once I say F net, I've put all the forces together. So it's in the same direction as the displacement. Are we together? So theta is 0 and cos 0 is 1. That's why I didn't even bother to put it there. Are we on the same page now? Okay. Okay. So my gradient now is equal to what? F net. So these are graph skills that we must be able to apply right across physics papers from question 2 to the end. There are 3 things you must do when you see a graph. I don't know if you guys remember. Gradient, gradient, gradient. When you see a graph, I'll quickly summarize for you. Number 1, multiply the axis. If the formula exists like we did this one, to check if the formula exists, what do? You find the area of the shape. Number 2, you divide the axis. If the formula exists like we did this, what do you say? Gradient. And number 3, if it's a straight line graph, which is the common one, what do? We rearrange and align with y equals to mx plus c. These are the 3 important things you do when you see a graph. Number 1, you multiply. So you say, look, let me quickly show you even if we don't, let me show you each of these graphs. And a good one to use will be velocity time graph. Look at your velocity time graph. It actually answers the 3. Velocity and time. For number 1, let's multiply, which is the product, right? Y times x. Does that exist? That's what we should ask ourselves. So if I multiply the axis, I'm having velocity times what? Time. But does that exist in terms of formula? What is it? Check. What is velocity? Okay, let's do it here. Velocity is what? Delta x over what? Delta t. Cross multiply, what do you have? Delta x equals to what? Velocity multiplied by, do you see that? So this, now when I say product, is the area. So the area will be equal to what? Displacement. In this case, this is a triangle. Half base times height. So if I calculate the area of this triangle, it's the same thing as calculating what? Displacement. So first thing is product, V times T. Does it exist? Yes. As what? Displacement. So the area of the shape becomes what? Displacement. Number 2. Can we find the gradient of this graph? Gradient, which is division, right? Or let's divide. Velocity over time. Does that exist? Acceleration. Change in velocity. Yes, it therefore means the gradient. Vertical projectile motion. We spoke about that just now. Number 3. It's a straight line graph. VF equals to VI plus A what? Delta t. That's the equation that would work here. But do you notice my time has taken the place of my x? And velocity has taken the place of what? Y. So I need to rearrange. Okay, let's leave this here and rearrange. A, you need to be conscious of where you place the variables. Check what I mean. Y equals to what? Mx plus. Do you notice that your Y, do you notice that your Y is velocity? What about your X? Time. So, just rearranging. What is M? A. And what is C? Your y-intercept would be your initial velocity. So those are the three things we do when we see a graph. Let me ask you something here. Quickly, just on the same question while you're on this page. Answer this very quickly. What will the product of this graph represent? What can you calculate here? Yeah, if you look at this graph, product is what? F times delta x. That's work. Find it in multiple choice. This is work done. So if I ask you to calculate work done, what shape is that? So first is product is F delta x. Does this exist? Yes. As what? Work. Oh, so length times breadth equals to what? Work. If I find the gradient, it will not exist. F over delta x. It doesn't exist. Does it? What is F net equals to delta P? No, it doesn't exist. It doesn't. F over delta x doesn't exist. Don't crack your head thinking, all right, it doesn't exist. But that's how we walk around. So we multiply, we divide, and we rewrite as. This will come out again in under circuits. That's one place they like it.
It kind of exists because if work is equal to F times delta x, then F over delta x is going to equal to. I don't know if you see what I'm saying. Like
If
you can't get F over delta x.
because they are together.
Yeah.
All right, so this is how it works. Are we okay with that quick crash course on graphs? Did it make sense to you? I could go on and on and on about all of, I love graphs. If you notice, I love graphs. Whether it's math or physics, I just love graphs. So this, I could create a million questions on them. I'm lying. Maybe 20 questions, not a million. Okay. Last year, November, there was a question they asked them on graphs.
You asked us a question last year about graphs, but for finance.
No, but even national physics,
Oh,
they asked them. I can quickly remind. Let me see. This was what it looked like. If anybody can check that paper, they had a triangle. It was a triangle. Oh no, not like that. It was a triangle. Was it like this? And they had F net or something like that. Yeah. If we multiply these two,
oh, that's
this is,
the other formula.
so if I multiply y and x, what do you notice? The product will give me what? F net. Does that exist? That's impulse. So they gave them a graph and they wanted them to calculate what? Impulse. What do you need to do? Since it exists, what's the area here? Half base times what? Height. So half base times height will be equal to what? Change in momentum or impulse. Did that make sense? Just trying to show you different things now. So first is I check the multiplication, then I ask myself, does that formula exist? I play around the original formula and work around it. All right? 2016, electrostatics. It was a graph. The question, the question was like this: 1 over r squared and f. Now, if I multiply the two, f times 1 over r squared would give us what? F over, will this exist? Okay, let's go. Since it's electrostatics, right? We go and write the formula. What is electrostatics? F is what? K, Q1, Q2 over what? It would not exist.
Oh, I see what you mean. But if you could say E is equal to KQ over R squared and F.
We will not get F over R squared. However, so product is wrong. What about the gradient? F, change in Y, over. So this is F divided by 1 over what? R squared, right? What will this be? F times R squared over. So what's our gradient? Go back to your equation. Can we get FR squared? Cross multiply, what do you have? So if I get the gradient of this graph, and they told them the charges were identical. So Q1 was equal to what? Q2. So gradient equals to what? K, and they told them to calculate Q. So I'll get this from my graph by using values, y2, y1 over x2 minus x1. K is a constant, 9 times 10 to the power negative 9. I'm done with my Q. So 3 in, please somebody just take a picture of this page and send it in. 1, 2, 3. That's how we deal with graphs. I hope that little short thing made sense to you. Are we okay? Somebody please quickly take. And I think we've done a few on Doppler, where it had to do with constant of 1.
Yeah.
Yes, we were rearranging. Free State. 2020, this is 2025, right? Free State 2023, Mpumalanga 2024. No, Mpumalanga 2023, Free State 2022. They were asking Doppler effect using graphs. I try. Okay. Can we answer the last part of this question quickly? We have just 5 minutes. I think we can. Let's try. Let's try quickly. I'm going to be working with you, but I just wanted to at least give me an attempt on the calculation. Calculate the net force. Check.
But now it's after they complicate the.
So already we know what net force is. It's the gradient. Lovely. As it moves from what? Y to what? Z. Okay, let's see if we can. From, okay, but hold on. What we need to do is on the graph, where are we, which gradient are we calculating? That's the thing I want. Okay, wait. If we look at the so we can align the distance here, right? We're looking for Y to Z. So what we have is 0 to 4, right?
From X, Y, into Z.
No, wait. No, it's going up. It's going up. I just want to see how they want us to figure out.
No, sir. There's two different frictional forces. So
Oh, yeah. There are two different frictional forces. You're so smart. So 0 to 4 is X to Y. And then 4 to 8. And it makes sense. It's a distance of what? 4. Y to Z. Logs. Yeah, but blocks here, I don't think they are very difficult. Okay, for this one already, 8 and 4. Okay. Now I've added a lot of bling. 160. Okay, I'll help you here. 1, 2, 3, 4, 5. So each block is what? 8.
Yeah, it's it.
There are 5 blocks there.
Yeah.
The distance here is 40. Each tiny block is 40 divided by 5, which will give us what? 8. And this one is sitting on the 1, 2, on the third block. 8 times 3 is 24. Great. So we're done with our gradient. So what's our gradient going to be? 160 minus 24. Guys, are we on the same page? I know now we're tired, but it got to be done. So 5.3.1. This is such a good question. You know how many kids will fail this? Because they won't know that gradient if they were not taught.
Never got it.
Yeah, this is the first time I'm looking at it. So beautiful. What did we say again? 160 minus 24 over what? 8 minus 4. What's your answer? 34. 34 newtons. I love it. I love it.
Yeah, they understand.
The magnitude of the frictional force experienced by the block as it moves from Y to Z. Okay, no, don't stress. We have our F net as 34, right?
Yeah.
Oh, and they told us it's moving at, it's easy. Moving at constant what? Velocity. That word was there, remember. So, 5.3.2. We were told it's moving at constant what? Velocity, which means the acceleration is 0. And that means the F net is also what? 0. The question is, how many forces are acting at this point? If draw a quick free body diagram would help you. The object was being pulled where? Up. So force applied is there. All right, if it's pulled up, friction is coming down, right? Okay, but do we need, okay, yeah. Friction is coming down, opposite direction of motion. FG pulling down as well, FG parallel. These are the 3 parallel forces. No, we're done. FG parallel, frictional force, force applied. Please let me know if my free body diagram makes sense. If it doesn't make sense, we're going nowhere. So let's quickly check. Give me thumbs up, thumbs down if the free body diagram makes sense to you. And we already know that the addition of those 3 forces is 0. Okay. So force applied, can I then say force applied should be equal to friction plus, will that make sense to you? The force pulling up is the same as the force pulling down. That's why F net is 0. And I think we were given force applied, if I remember reading very well. 45. So case closed. And the angle is what? 25. So we. What was the mass? 8. I remember saying an 8. Yeah. So what's our force applied?
I just said 45.
45 newtons. Okay, 45. We don't know friction, right? But what is this? mg sine. Okay, use theta, use alpha. What is my m? 8. What is my g?
9.
Sine what? 25. Is it 25?
Yes.
Okay, please get me FK. Then we're done. Check. But this is such a beautiful one. I love it. Sorry?
11,87.
We're done. 11,87 newtons. Guys, are we okay? Did it make sense? So the idea is keep an eye on what you have. It will always guide you. Always guide you. But I'm sure a lot of people would have looked at the question and like, oh no, we're not going to be able. Okay, please let's look at the last one. The power dissipated by the block from X to Z. What is power? That's the first thing we need to ask ourselves. What is power? Power is work done divided by delta T, or power is force times what? Velocity. Okay, from X to Z, what is it that we have from X to Z? Let's check quickly. From X to Z, what can we... We're looking for power, right?
Don't have delta T, right?
Okay, we don't have delta T, right?
We don't have velocity either.
No, but hold on. The ball moves at constant speed in the sections XY and YZ. Okay.
You don't have enough force, right?
No. How many marks is this? I want to see something. 4 marks. Because I'm thinking of something, but it might not make sense. Since we're looking at the entire distance.
Different friction.
And yeah, that's what I'm trying to balance. Different frictional forces. Oh, wait. Power what? Power dissipated. I'm thinking of power dissipated from X to Y.
And then Y to Z.
And then Y to Z. Because they are different powers. Since they are different frictional forces. And power is what? F times V. Okay, but we don't have V, right?
Yeah.
But hold on. I think we can work out V.
Kinetic energy.
Yes.
Yeah, we can. Because half M is way.
Okay. My brain is tired, but let's see. If anybody can think quickly. I'm lazy. I'm thinking, but I'm lazy to write. Okay, guys. Okay, let's see. Do we agree that we can get F net for between X and Y? Okay, can you please get that for me, the gradient? That's going to be simple, 6.
0 and 0 using that.
Yeah, I'm using 0 and 0. And I'm using 20, this was 24. And 24 divided by 4, 6. We agree. So, we're using the same concept there. So this one is 6 newtons. And what was this one? 34. 34 newtons. Okay. So if power equals to... So I have F net, I have kinetic energy, I have distance. Alright? Let's just check something quickly. I'll release you now. You're not writing tomorrow, so it's fine.
I think that is equal to delta K, but in this instance, delta K is 0.
Not really. Yep. Okay. What is it we have again? We have F net, right? For the first between X and Y, we have 6 newtons. What else do we have? Distance is 4.
Mass.
We have mass as 8. Okay, I'm looking for power. W. Alright?
We can use this.
Or we said power is force. Now, this is where we are having an issue, right? Velocity. Distance over time. But we don't have time.
Let me better export these.
Let's see.
So we can get the wall.
Oh, no, wait.
So what if we use equations of motion to find the time?
The thing is, we don't have... Okay, how would we do that? If the velocity is constant, acceleration will be 0. Okay, they're trying to give me some degree of gray hair now. But hold on. Why are we stressing? Wait. Fnet is ma. Right?
Acceleration is 0.
No.
Is equal to 0.
Bro, wait. But Fnet equals to 0.
We're gonna have to use what you say, equations of motion.
Oh, wait. Why is Fnet 0 again? Because of constant velocity.
We can use what you say.
Okay, I'm beginning to have a bit of a problem somewhere. Like I'm having a conflict in my head. Wait.
Use what she said.
Wait, hold on. Let's go back. I'm beginning to have a bit of a conflict somewhere in my head. All right, guys, we are all thinking, so everybody bring in your thinking caps.
Because initial velocity is 0. Acceleration goes to 0. How can x equal to 0?
No, hold on. What was the first question we did?
I see what. So
Calculate the net force experienced by the steel ball. Okay, by the steel ball. It experiences. Okay, but we do have. Why did they tell us to calculate friction there? Power dissipated by the block. So it's overcoming what? Friction. What is F? F. Guys, don't all be dumb.
So can you go back to the question?
Okay, wait, you Sarah. As I'm thinking right now, I want us to quickly work out something. Can we work out the work done by friction? I think that's possible. Because we have F delta X cos theta. That cos theta is 180. What is that friction? It was 11,87. All right. This is between where? 5.3.2. Between Y and Z. Oh, there's going to be a problem, but let's see something. Between Y and Z, 11,87 multiplied by 4. Cos what? 180.
Negative 47,4.
Negative?
47,4.
Okay. I'm tired. With this, I can get the power of friction. Right? What about work done by gravity? It is gravitational force, mg sine alpha delta x cos what? Theta. What is the m? 8, 9,8 sine 25, 4. It's in the direction of friction, right? Okay, please give me an answer here.
Negative 132,5.
Negative 132, now, if you remember the free body that we had, it was like that, right? We had two forces working downwards. We agree? Okay. It means, what am I looking for again? Power. I'm playing. What was I thinking of that brought me here? Okay, you say that. Can you take me back to what you wanted? I think I lost something right now while talking. I thought I saw my answer.
The graph, the drawing.
I thought I saw something in my head. Okay, guys. If we don't get under 5 minutes, I'm tired. We'll figure it out. I'm just tired. Okay, let me look. Okay, 5 minutes. By 2015, everyone goes home.
Yeah, so we can get velocity. Because isn't what's Fnet is equal? No. Yeah, we can. So gradient is equal to what? Is equal to change in kinetic over distance. Then gradient is equal to, we got our kinetics.
Oh yeah, we can get velocity
Yeah.
because we have Fnet,
Yes.
we have mass,
Yes.
we have the distance,
Yes.
so we can get velocity.
Yeah.
Sometimes you're very smart. Just sometimes. Just sometimes. Sometimes you're very smart. But is it making sense though? Because we can use Fnet equals to that over, and we have the displacement. Sometimes you just show me some spark, and sometimes I need a battery charger for your head. Okay, 5.3.1 between Y and Z. Okay, yeah, we can. We can. Makes sense. I was just faffing here. Quickly. We said F net. So please follow. We don't want to come back. We said F net is what? Change in the kinetic energy over what? Delta X. Do you remember that, right? Okay. So our F net was 34.
Yeah.
So 34 is equal to 1 over 2 mv squared over what? Delta X. Right? Sometimes I don't know what's wrong with me. Keep this thought, please. Sometimes I don't know what's wrong with me. Sometimes I don't know what's wrong with me, but I think sometimes. Okay, what would this be? I might be lying here. We might be lying here, though.
Yeah, because of the.
So what's the
change
mass?
in kinetic.
The mass is 8.
Yeah, it's 5 comma 8.
5,83.
But you are lying.
Why are we lying?
Because VF minus VI.
Yeah, you see, I'm trying to hide there.
No, but VI is 0.
It's not 0.
It is. It's Saturday rest. Saturday rest. You're not wrong. Saturday rest.
Oh, really?
Yeah.
Silent rest.
Yeah.
Okay. What is this one is between which one and what? Y and Z. Okay, let's check something. What about between X and Y? We got the gradient to be 6. So 6 equals to 1 over 2. What is the mass? 8. Distance is also 4 v squared.
6.
V c-
No, you must substitute get 2 comma 45. The initial now.
No.
2 comma 45.
We just want to get that it's constant velocity at that in that frame.
No, you say VF squared minus VI squared. Is that what you say? Yeah, but it is minus 0.
This is
So
between
that's an ambiguous.
this is between X and Y first, though. Okay, what? Give me an answer here first. I know what you're talking about.
2 comma 4.
The y is it.
Okay, give me this one.
2 comma 4.
2,45. So the object first was moving at 2,45. All right. Then change to what? 5,3. Do we agree? It's constant.
But the friction changes.
Yeah, that's why the velocity is changing.
Different ones.
No, but it wouldn't be initial for this one.
No, it's constant velocity. It's constant velocity.
So it doesn't make sense.
Huh?
It doesn't make sense.
How?
So where is the 6 coming from?
Where is what?
The 6 coming
The
from.
gradient of xy. We mentioned that on the graph. That's the 6 and that's the 34. And you would see that the 34 has a greater speed than the 6. Look at the slope. I know what you're trying to, I know what you were conflicting about. Okay, but how do we then bring all of this into play?
Power 1 plus power 1.
All right, so power is F times what? V. Power is F times V. Okay, I'm going to have to hope we are correct, but I'll check later. But I want to always at least get the wrong answer than not do it at all. What is power here? 34 times 5,83 plus F here is what? 6 times 2,45.
212,92.
212,92. All right, they made it interesting at the end anyway. Yeah. But I don't know if, okay, look, guys, we might be wrong here. I'm openly going to say we might be wrong, but is this attempt making a bit of sense? A bit of sense. It's an attempt. I love the question. I'm actually going to sit down and look at it. We are looking at what Shami was saying.
No, but then he's right, because in the start, right, that one day,
Was
Y is right. But in XZ, we have to say this 5,83 minus 2,45 because that's the initial velocity is starting with.
I don't think so because it's constant.
Yeah, I also
You see, once we say that, then it's going to increase. I don't know if what I'm saying makes sense. All right, guys, I don't know if just looking at this part alone, this is what matters. Let me just try to re-echo what we did here. Okay, it may not, we're going to check again, but this is what we try to do. Okay, so we try to use where we started. We went back to where we started from. To say F net is that over delta x. We got this gradient as 34. Everybody's fine with that, right? Half mv squared over delta x. M is 8. Delta x is 4 between each. And then we use that to get our v, square root. The velocities are different because the friction is also what? Different. We did the exact same thing to get what? The velocity for the second part, or the xy part. Gradient again is 6. Same formula, velocity. So the power dissipated in the first is different from the power dissipated in the second because of the different frictions. That's why we said power is force times average what? Velocity, which is constant there. So 34 times that plus 6 times that to give us that. Did our attempt make sense? Quickly. Did our attempt make sense?
can you explain why Shamil's way homework?
I'm still thinking about that because the distance between, because it means you're starting at 8 already, but then you're starting at 2 already.
Good night, everybody. Shamil, please leave me alone. No, I'll tell you why. I get what you're saying, but this is what comes into my head. That because the velocity, see, when I say the initial velocity and the final velocity, it means the velocity now is changing. So the velocity will start from 2.45 to 2.46 to 2.47 to 2.48, but it's constant.
Yes.
No, but that makes sense beautifully.
No,
Yes.
the velocity, see, okay guys, we are done. It's just, oh, they've already gone. But Shamil, no, Shamil, check. You get my point now, right? To say the velocity from here to here is the same.
Yeah.
The velocity from here to here is the same.
Yeah. But it did start.
Good. So now if I then bring in that initial velocity here,
Yeah.
all right, and calculate, so let's say velocity here is 2, just for argument's sake, and you say the velocity here is 4. It's not constant anymore.
Let's go 2.1.
Shamil, it's like saying you're driving.
Yeah.
Check. You're driving to a particular point, 10 meters per second. And then you move to 12. And then stay on 12.
You don't just jump, it has to go, it has to increase gradually.
Okay.
So from here, so whatever happened, maybe the force changed. Whatever happened kept the velocity constant at this point. So if I say my initial velocity is this, then it means my velocity was increasing small, and the graph would not be correct. But I think we are right. I have a bit of confidence that,
Yeah, we are right.
I think we are right. Anyway, good night. It was a beautiful question. Yeah, at least they brought in something juicy at the end. What you were waiting for.
Yeah.
Good night.